All right, guys, welcome to Monk's Kitchen for another episode of Science with Libby Monk. And what we're going to be doing today is a little experiment where we demonstrate energy transfer in water. And so Libby has two beakers here.
But I'm going to fill this one with hot water.
Okay. And while she's getting the tea kettle here, we want to talk about kind of the intention here is to look at energy transfer by watching food coloring disperse through the water. So we have two glass jars. Each one has a sample of hot and then cold water. Obviously the tea kettle Libby's pouring with is hot water. And then the other beaker is cold water. And what we're going to do is simultaneously, Livy's going to add food coloring to each of these beakers.
The red is hot and the blue is cold.
So do it at the same time, hon.
At the same time.
Yep. And what we're going to watch is the food coloring disperse through the different temperature water. There you go. That's good.
One more drop.
Okay. And so what we're looking for here is a comparison between the mixing rate, because the mixing rate is directly related to particle motion. And so those water particles in the hot water are moving much faster and then colliding with the food coloring particles. And you can see that the water consequently is mixing at a much faster rate. If you look at the cold water, you can see that the food coloring is settling to the bottom, but we don't have nearly the same amount of mixing because those water particles are moving much more slowly and colliding with the food coloring much more slowly. And so we don't see the same rate of dispersion through our cold water solution. Mm-hmm. All right, so we're gonna go ahead and look at that here with the drawing. And Livy's gonna grab the markers and she's gonna kind of illustrate what's happening. So we have cold water on the right. And I'll try to move the jars in front. And we have hot water on the left. And she's just gonna show kind of a comparison of mixing rates there.
I need to think about that.
Okay. So which one's mixing faster, Livy?
This one?
Okay, so that's above the water. So do it down below the ice cubes there. Show kind of where the food coloring is. Yep, that's good. Nice. So it's not fully mixed, right? Because if you look at the jar, there's still some food coloring kind of sitting there on top of the ice cubes. And then let's do it the same thing for the hot water. Show me where the hot water and the food coloring is. There you go. It's all throughout our system.
And I can draw some dots to represent molecules in the hot water. Because if you look very closely, I don't think you can see it. You can see those tiny dots at the top.
Tiny dots, huh?
See?
Well, what I see is that the food coloring is completely mixed.
But look closer.
I can't see anything. Oh, yeah, that's just some little air trapped in there.
Well, I can draw the air bubbles right here.
Okay. Now let's take one more look at the cold water, and you can still see that the food coloring hasn't fully mixed. So those particles are moving much more slowly, right?
It's like it's not fully mixed like the red. It's at the bottom and it's at the top.
All right, cool. So we've learned that energy and transfer in water happens much more slowly in cold water, as evidenced by the lack of mixing of the food coloring, compared to hot water, where the food coloring mixed almost completely and pretty fast. So thanks for watching. Say goodbye.
Bye.
Bye for now.